Dear students, this is Dr. K. Saravanan, Associate Professor, Department of Information Technology, R&D Engineering College. My dear students, now we are going to discuss pin diagram of 8086, that is signals of 8086 in detail. This shows the diagram of your 8086. This 8086 consists of 42 pin IC. It is work under two modes, one is maximum mode and other one is minimum mode. We will see the pin one by one and we'll discuss about this. The first pin is power supply and frequency signals, that is VCC. It uses 5 volt DC supply at VCC pin number 40 and uses ground at VSS in pin number 1 and 20 for its operations. And next pin is clock signals, pin number 19. This clock signals is provided through pin number 19. It provides timing to the processor for operations. Its frequency is different for different versions, that is 5 MHz, 8 MHz and 10 MHz. Now we'll discuss the address and data buses AD0 to AD15. These are 16 address / data bus. AD0, AD7 carries low order byte data and AD8 to AD15 carries higher order byte data. During the first clock cycle it carries 16-bit addresses and after that it carries 16-bit data buses. Data and address / status bus, that is A16, A17, A18 and A19, that is S3, S4, S5, XS, pin number 35 to pin number 38. These are the 4 address / status bus. During the first clock cycle, it carries 4-bit address and later it carries the status signals. Coming to the pin number 34, that is bus high enable bar / S7. It is pin number 34. The BHE stands for bus high enable. It is available at pin number 34 and used to indicate a transfer of data using data bus D8 to D15. This signal is low during the first clock cycle and thereafter it is active. And next one is read bar, pin number 32. It is available at pin number 32 and it is used to read signals for read operations. And next one is ready pin. It is available at pin 22. It is an acknowledgement signal from IO device that data is transferred. It is an active high signals. When it is high, it indicates that the device is ready to transfer the data. When it is low, it indicates it is in the wait state. And next is reset. The reset is available at pin 21 and it is used to restart the executions. It causes the processor to immediately terminate its present activity 2. This signal is active high for the first 4 clock cycles to reset the microprocessor. And next one is INTR. INTR, it is available at pin number 18. It is an interrupt request signals which is sampled during the last clock cycles of each instructions to determine if the processor considered this as an interrupt or not. NMI, it stands for non-maskable interrupt. It is available at the pin number 17. It is an edge-triggered input which causes an interrupt request to the microprocessor. Test pin. This signals is like wait state and it is available at pin number 23. When the signal is high, then the processor has to wait for idle state, else the execution continues. YUN. It stands for maximum / minimum. As available at pin number 33, it indicates what mode the processor is to operate in. When it is high, it works in the minimum mode and vice versa. INTA. This is an interrupt acknowledgement signal. ID is available as the pin number 24. When the microprocessor receives the signals, it acknowledges the interrupt. And ALE stands for address latch enable, and it is available at pin 25. A positive pulses are generated each time the processor begins any operations, and this signals indicates the availability of a valid addresses on the address data lines. DEN, it stands for data enable, and it is available at pin number 26. It is used to enable transceivers 8286. The transceiver is a device where a separate data from the address slash data bus. TT/R, it stands for data transmit or receive signals, and it is available in pin number 27. It decides the direction of data flow through the transceivers. When it is high, the data is transmitted over and vice versa. M/IO, this signal is used to distinguish between memory and IO operations. It is in the pin number 28. When it is high, it indicates IO operations. When it is low, it indicates the memory operations. It is available at pin number 28. WR. The WR pin, it stands for write signals, and it is available at pin number 29. It is used to write the data into the memory or output device depending on the status of M/IO bar signals. HLDA. HLDA, it stands for holds acknowledgement, and is available at the pin number 30. This signals acknowledges the hold signal. HLDA, this signals indicates to the processor that external device are requesting to access the address slash data bus. It is available at the pin number 31. QS1 and QS0. These are the two Q status signals are available in pin number 24 and 25. And these signals provide the status instruction of the queue. Their conditions are when QS0 is 0 and QS1 is 0, the status is going to be no operations. If QS0 is 0 and QS1 is 1, the status is first byte of opcode from the queue. If QS0 is 1 and QS1 is 0, the status is the queue is empty. If QS0 is 1 and QS1 is 1, it means the status is subsequent byte from the queue. So the S0, S1, S2. These are the status signals which provide the status of the operations, which is used by the bus controller 8288 to generate memory and IO control signals. These are available at pin number 26, 27 and 28. Now we'll see the what is status of S2, S1 and S0. If all are 0, 0, 0, the status is interrupt acknowledgement. If S2 is 0 and S1 is 1 and S0 is 1, it is going to be the IO read operations. If S2 is 0 and S1 is 1 and S0 is 0, it is going to perform the IO write operations. If it is 0, 1, 1, it is going to perform halt operations. If it is 1, 0, 0, it is going to perform opcode fetch. If it is 1, 0, 1, it is perform the memory read, and 1, 1, 0, it will perform the memory write, and all these are 1, 1, 1, it is going to perform the passive operations. And next one is log signals. The log signal is pin number 29. Thus, log signals, when the signal is active, it indicates to the other processor not to ask the CPU to leave the system bus. It is activated using the log prefix on any instructions and is available at pin number 29. And last one is RQ/GT1 and RQ/GT0. And this are the request and grant signal used by the processors requesting the CPU to release a system bus. When the signal is received by the CPU, then it sends acknowledgement RQ/GT0 as the highest priority, then RQ/GT1. And that's all about the pin configuration of 8086. Thank you students for listening to my lecture, pin diagram of 8086. Thank you once again.